Hey everyone, I'm here. I had this great talk planned out for you, like 30 minutes worth of content, and I had it all ready to go. And then they said, hey, you're the keynote. And I was like, great, except I have to cut a lot of stuff out because I've only got 15 minutes. So we'll start here with the ML pipeline implementation with Kubeflow. How to streamline machine learning workflows efficiently. So yeah, that's a handful, I guess I should say. So I have a sign language interpreter right here who's voicing for me, and she's also got the clicker, so I'm not the one advancing. I am Rob Koch, and I serve as a principal data engineer within Slalom. I'm deaf, and I use American Sign Language. I work with software, data, Kubernetes, you name it, the whole gamut. So a picture's worth 1,000 words, right? I'm sure you've heard that if you're an English speaker. And so with sign language recognition, it's quite difficult. What we need to succeed with that is really, we need the context. It's very spatial as a language, so when I'm signing here, I'm talking about the future. It'd be out here in front of me. If I'm talking about the present, it's right here, closer to my body. And if I'm talking about the past, it's behind me. So you can notice this, machine learning, whether it can recognize that or not, is difficult. And then the data component of that is sign language recognition is quite far behind compared to voice recognition because they're about 20, 25 years ahead of us. And they've got programs that can do speech to text fairly easily, but sign language is relatively new with that, so we've got a ways to go to catch up. And then whether we're using LLMs or not, we don't know, right? We're a little bit slower to get to that point with the query prompts and waiting for that. We can't wait for that when we're doing sign language things, so it's a different approach in that way. So this photo here, you'll notice that there are landmarks on my palm. And this is what's important for us with the machine learning workflow. You can see here it's quite challenging with fingerspelling to be able to capture the movement. So that's why I wanted to show you this image, but I will be showing you a demo momentarily. So with Kubeflow, it's an end-to-end workflow management system. And we'd like to be able to implement that for sign language recognition and have a unified platform so that anyone could use that. If you hired somebody off the street, they would be able to just readily available use that platform. We want to be able to automate all of these things consistently, of course. And then when the data is coming in, we want to make sure that that is automated, that it comes with versioning, and that if something's not working, we can go back to a previous version. And really, that's a big thing here in the KubeCon and the community here. It's got a great ecosystem, and we've got active development happening all the time. There's integration tools being able to plug and play, pulling data in with different connectors, etc. So now with Kubeflow, best practices, putting that all together for the implementation, it's already got that ML ops built in. So now we'll get into kind of the key components of sign language recognition and processing with AI, ML, inference, and orchestration. So how does sign language recognition work exactly? We use computer vision models for real-time video processing. Pre-processing is happening for a lot of that because we have a lot of videos and images with various skin tones, different backgrounds, what shirt I'm wearing. There's a lot of, if I have a loud shirt on, there's a lot of noise introduction there. And if there's a lot of noise in the background, equally the same thing. Not necessarily noise to you in the way you hear it, but I'm talking about visual noise. So if I'm spelling the word how, H-O-W, there's a lot of noise already. It's just 3 letters, but there's a lot of noise. Because when you're doing that transition from the H to the O, it kind of looks like a C in the middle. So we're trying to figure out how to clean that noise out. It's a technical challenge that we'd faced here. We've used an overlay framework. So that hand with the landmarks that I showed you earlier, within that image, there are various points for X, Y, and Z axes. So interacting with that and trying to capture the entire grand scheme of my hand and what's happening there. The models might look in one direction. If I'm signing, a word and the camera is looking from the front, but if there's a different perspective of looking from the back or the side, that can change everything. We always want repeatability, and the role of AI and machine learning here is to be able to preserve not word-for-word translation, but we want to be able to do the transformation within the context of what's being signed. So moving that to the next word, understanding what that is going forward, and that's where the LLM comes into the picture. Also, I wanted to add that the LLM, when we're using that for signing cities, for example, in the United States, some signs are exactly the same depending on the context. So we have Austin, Texas, and Albany, New York, and they have the same sign. So the LLM needs to be used to understand which you're talking about within the context. So, we're here at KubeCon, so of course we have a Kubernetes foundation. This is providing the seamless integration with the process and the data handling, the preparation, everything that's repeatable. We can add words, signs, and integrate that in the repeatable pattern, and optimize for video processing as well. So when we're processing that video, we want to leverage the latest and greatest CPU and GPU, so we don't have to change anything that's going on out there. Leverage what's currently new in that space and be able to then include Kubeflow to run against that. Also, the scalability of Kubeflow is a great opportunity for using that as far as getting a faster outcome. If I had a longer amount of time, I would be able to go in very depth into this. I know there's some machine learning people out here that probably get it, but I just wanted to demo how complex this project was. There's a lot of complexity. We've got the UI client, we've got the inference service. Those are going back and forth quite a bit. And then behind the scenes, we also have models that are running on Kubeflow and pipelines that are adding the data, as well as using Kserve for optimizing the inference. Also, we can add the notebook integration. You can tweak things there to be able to test your models, etc. So here's the demo. So you can see what I'm doing here with my hands. You can see all of those landmarks that I was speaking about with the X, Y, and Z. Those are being passed to the model, and the inference service is trying to figure out what I'm trying to say. So it says, welcome to KubeCon, everyone. So when we started this project, we were using regular images of hands, and maybe not, retrieving thousands of people's hands. Really, that task can be impossible for me to prepare for here. They let me know, I think in January, so I had limited amount of time. We had a way to shortcut it a little bit with using Labs and MediaPipe and being able to identify those landmarks, so we didn't have to worry about the background, the colors like I was talking about before, identifying those vector points, and our model improved tremendously. It was able to understand it a lot better. And so these landmarks and shapes here were identifiable and reducing the noise in the environment. You can see here that we were talking about scale within our project as well. If you did something too far away from the camera, it would kind of blend your fingers together and it wouldn't really be able to recognize those landmarks. But then if you backed up a little bit or made it into a certain space, then it would work better. And then we decided to add shift and scale so that we could normalize the data from 0 to 1. And with that, in machine learning, the concepts with the zeros and ones, 0.35, whatever that may be. So those different vector points, adding that shape and size with the shift and scale, it didn't matter as much. So it wasn't really much difference between the two. So we experimented with that. And wow, it was difficult, definitely not an easy task. So I'll have an interesting story a little bit about this part. So with machine learning and analyzing the data and putting all the inference and the models and everything, it worked great. But now we were to the actual testing. So with P's and Q's, the phrase, mind your P's and Q's, right? So we had a problem with our P's and our Q's. If you're looking from the camera from the front, it wouldn't recognize this, the P or the Q. And I thought, that's really interesting that it's not being able to recognize that. And I got my team together and we had a long discussion about what that was what was causing that. And then I thought, oh, right, the images that it's using is showing the P from the side. So of course the camera's not going to be able to recognize that. So that means now we need to add the different views of the camera from front, side, top, back, etc. And so we don't naturally sign it in this direction. So we had to make the P look like this from the front with the X, Y, Z. So it was a really interesting discovery. And I just wanted to show you why the authenticity matters. If it's a hearing person, maybe you don't realize what a deaf person looks like when they're signing in naturally. And so if a hearing person was doing this with these images, they may not understand that it would work. But if you turn it facing forward as a deaf person would sign, then that's the difference there. So the roadmap for the future is the infrastructure is, of course, adding more words and making it kind of a commonality, partnering with data collection or working with people that are all over the world, just bringing in more data. That's our next challenge. So I just wanted to end a little bit here with a thank you. If you want to learn how to sign, thank you. This is what it looks like. So you're welcome to find me a little bit more about that. I also wanted to shout out to my colleagues that made this keynote and project successful. And I've got the team here. We were all learning about the technology, collaborating, and really it was best of all, really, we required a lot of perseverance. So I just wanted to shout out to these two folks, Kamal, John, and Ali. So thank you so much for your contributions here. And then, of course, if you have further questions and you want to contribute, you want to get involved, please feel free to stop by the Deaf and Hard of Hearing Working Group kiosk in the Project Pavilion in the expo space. I'm happy to talk and reach out on LinkedIn, so you know where to find me, multiple avenues that way. And I also want to add before we close, there is a new mentorship program that the TAG implemented within CNCF, contribution strategies with the mentorship program here. So underrepresented groups, if you want to be part of the mentorship program, please sign up. Thank you, everybody. Enjoy your KubeCon.
That was incredible.